Hi, in this lesson we're going to be working in our Theme 12 booklets on pages 14 and 19. This particular unit is looking at the geology of Britain and how Britain's geological history has evolved over the last 600 million years or so. What we get as a consequence of all these changes is this map of Great Britain. When we start looking at it, we can start to realise some of the huge geological diversity that we have within what's actually a relatively small island. We have a huge range of different rocks, of different ages, different types, different processes. There's a huge range as well of geological resources, perhaps that helped to fuel the Industrial Revolution that built Britain into the prosperous nation it became. But it's also a source of scientific fascination. Now, page 14 has got a series of questions which allows you to explore something of this geological diversity, just to start picking out some of the key features you can see on this map. Have a go at those questions, see what you can come up with. The second part of this lesson is to look at some of the evidence that we have for Britain's geological journey. These are the questions on page 19 that start to tie together all the ideas that we've been looking at in this theme. So, now's the time to press pause, have a go at those questions on pages 14 and 19 and see what you can come up with. Okay, let's see what you've come up with. The first question asks you which bits of geological time are missing from our record, which periods might be absent. And the answer is none. Britain has an incredibly diverse range of geology in terms of its rock ages. There's really only a tiny piece of the Neogene that's missing from our record. Second question was looking at the distribution of these rocks. If we imagine going on a journey from Ullapool down to London, so from the far northwest down to the far southeast of the country, we see a general progression in the age of rocks. With the exception of the Midland Valley of Scotland, those rocks are going to get younger. In Britain, the further north and the further west you go, the older the rocks get. The further south and the further east you get, the younger the rocks get. Now, the areas of metamorphic rocks in Britain are predominantly in the Scottish Highlands. These are the oldest rocks that we find in Britain. The very oldest ones are the purple coloured ones we can see here, particularly in the Outer Hebrides of Scotland. The intrusive igneous rocks, again, are predominantly in the Scottish Highlands, but also we find them in the Lake District and in Devon and Cornwall. There's a few smaller ones in North Wales, but those are the three main areas. Now, the fact that we find most of the intrusive igneous rocks and most of the metamorphic rocks in the same place in the Scottish Islands does suggest that these processes that form them are related. The fact that these areas as well are mountainous shows us that the formation of mountains, the process we call orogeny, metamorphoses rock and leads to the intrusion of plutons. The next part of this question looked at a few of these key features. So the rock there with the horizontal lines is Jurassic. The age of the rocks that are shaded in with dots are Devonian. In the areas marked X, we find rocks of Permian age. And within those areas, we can find extensive deposits of salt that we use for food, for spreading on the roads as a chemical ingredient, and also gypsum, which is an important ingredient in making plaster. Question 4. The rocks that are labelled at Y are Carboniferous in age. The resources we find there include coal, much less important these days, and limestone, which is an incredibly important resource. Now, the type of erosion we find up round E is glacial erosion. The sea lochs up there are fjords. They're glacial valleys that have been eroded by glaciers during the Quaternary and then flooded by the sea as the sea level rose. The dotted line from G to G is where the two continents were joined during the Caledonian orogeny. Strangely, for something that's possibly the most important event in Britain's geological history, if you actually go to that area, which almost follows the English-Scottish border, there's nothing to see. It's not exposed at all. It's covered up by younger rocks all the way across. A lot of the other big faults marked on your map, you can go and visit. But that one, there's no sign of it. The record for that is far more subtle. We find it in the fossils and the rock types telling us that the two continents joined. And finally, underneath area H, we have plutons that were intruded in the Variscan orogeny. Dartmoor, Bodmin Moor, Land's End, the Scilly Isles are all little offshoots of one enormous pluton that's underneath pretty much the whole of Devon and Cornwall. Moving on to page 19. If we use this graph, the two statements that are true. The rate of drift was more rapid between 450 million years and 250 million years. We can see a steeper gradient there for the graph. And the rate of drift slowed during the Mesozoic and the Paleogene or Neogene. Britain crossed the equator in the Carboniferous period. You can see where it passes through 0 degrees. And of all those bits of evidence, the only one that doesn't support continental drift is mass extinction. That's perhaps more of a consequence of plate tectonic movement rather than evidence for it. Two pieces of evidence that can be used to show Britain's latitude. We can get rocks from different environments. The fossils and animals of plants that live in those periods of time that perhaps couldn't live our current latitude. And we also get magnetic records in the rock if you think back to theme 7. Finally, if we calculate the rate of northward drift, it's about 21 degrees of movement in that 100 million year time period. About 2,331 kilometres. Divide that by 100 million years, and we get a rate of 2.3 times 10 to the minus 5 kilometres a year. So, we can see that there's lots of evidence for Britain's changing environments through time. As geologists, we need to be able to pick out that evidence and see how it shows that our latitude has changed from maybe 40, 50 degrees south during the Cambrian, right the way up to 50 degrees north during the Quaternary. That long journey that Britain has been on is part of the reason we have such geological diversity.